In this lecture, we study the CE analysis. In the last lecture, I explained the CE amplifier. Now here this is a two-port network. Consider it as a CE amplifier. For that, Vs is applied through the RS and output is taken across the load ZL. Now for this, if I draw the H parameter model, so then it look like this. So already in the last class, I have explained the H parameter model for the CE amplifier. Now HIE, IB, HRE, VC. It is now here at the output we are taking only, instead of taking the VCE, we can take it as a VCE or VC. Input side it is a VB. This is VB or VBE. Now here I am taking VB and IC, HRE, IB. This is a dependent source which is depending on the input current, and this is a dependent source which is depending on the output voltage. Now this is the hybrid model for the CE amplifier. Now from this we need to derive few parameters, nothing but voltage gain, current gain, input impedance, output impedance we need to calculate. Now how to calculate that we will see here. Now input side it is a loop and output side it is a node. So whenever we need to put the expression at the input side, we have to take the KVL, and at the output side KCL. So now first we will derive the expression for the current gain. Current gain AI. Now for this we need to derive the expression. Now how to write the current gain AI? Current gain AI is equal to output current divided by the input current, that is nothing but IL divided by the IB. Now where if you see here, IL is in this direction which is flowing through the ZL, and IC is the opposite direction. Now where IC is in the opposite direction to IL, we can rewrite this expression as minus IC divided by IB. So now here from this expression, now I will write IC is equal to what can we write? IC is equal to HFE IB plus HOE VC. Now where VC is equal to what can we write? VC is equal to ZL into IL, that is equal to minus IC into ZL. So if I substitute this expression in this, then IC is equal to HFE IB plus HOE. Now here we have to put the, instead of VC we have to put minus IC ZL. So now from this I am writing all IC terms together, and IC I am taking out. With that I will get 1 plus HOE into IC. Now here I will get ZL, HOE, ZL is equal to HFE IB. So now I need to write the expression IC divided by IB. IC divided by IB. IB I am bringing to this side, and so 1 plus HOE to that side. HFE divided by 1 plus HOE ZL. Now this is IC divided by IB. Then what is AI? AI is equal to minus IC divided by IB. So AI is equal to minus IC divided by IB is equal to, I need to put minus over here, that is minus HFE divided by 1 plus HOE ZL. Now this is the expression for AI. Now AI expression I am writing here. AI is equal to what? Minus HFE divided by 1 plus HOE ZL. Now this is the current gain expression in the CE amplifier. Similarly, we need to calculate the input impedance, output admittance, and voltage gain. Now let me calculate the input impedance. Input impedance ZI. Input impedance ZI is equal to, now ZI we need to calculate. Now what can I write? ZI is equal to, ZI is nothing but what? VB divided by IB. So VB divided by IB. Now if I write the expression inputs, apply KCL at the input, then what we get? VB is equal to HIE IB plus HRE VC. So where VC is equal to what can we write? Minus IC. Now here VB HOE IB plus HRE is equal to what can I, VC is equal to what can I write? Minus IC into ZL. So where now here VB is equal to HOE IB plus HRE. Now from this AI is equal to what? AI is equal to minus IC divided by IB. Now minus IC is equal to what can I write? AI into IB into ZL. Now I am taking IB outside. Now VB is equal to IB I am taking out, and I will get HOE plus HRE AI into ZL. So now from this VB divided by IB I am writing IB is equal to HOE plus HRE. Now what is AI? AI is equal to minus HFE divided by 1 plus HOE into ZL, into here also one more ZL is there. So okay, now from this now if I am taking ZL out, then I will get, now this VB by IB is equal to what can I write? ZI. So ZI is equal to HOE minus I am taking out, so minus HFE HRE, and ZL I am taking out and cancelling with this ZL, then 1 divided by ZL is plus HOE. So 1 divided by ZL we can rewrite it as, so ZI is equal to HOE minus HFE HRE divided by YL, admittance. I am writing 1 divided by impedance is nothing but admittance plus HOE. This is the input impedance in the CE amplifier. Now next, now here I am writing the input impedance. ZI is equal to HOE minus HFE HRE divided by admittance, output admittance plus HOE. Now we need to calculate the voltage gain. Now voltage gain, 4 parameter we need to calculate. Now 2 already calculated. Now next one is voltage gain, AV. Voltage gain AV. Now what is AV? AV is nothing but what? Output voltage divided by input voltage, that is VC divided by VB. So VC is equal to what can we write? VC is equal to minus IC ZL divided by VB. Now here AV is equal to, now minus IC, what is minus IC? AI is equal to minus IC divided by IB. Now I need to substitute this value over here. So AV is equal to AI into IB into ZL divided by VB. Now IB by VB is nothing but what? This is 1 divided by ZI. So AV is equal to AI into ZL divided by Zin. So this is the expression for the voltage gain. Now here AV is equal to what can we write? AV is equal to AI into ZL divided by Zin. Now this is for the voltage gain. Similarly, we need to calculate the expression for the output admittance. So output admittance is nothing but Y0 or YL. Y0, okay. So Y0 is equal to what? Now admittance Y0 is equal to, we can write it as I0 divided by VC. I0 divided by or VC divided by IC divided by IC divided by VC. Now there we have taken IC and IL. So here IC divided by VC. Now take the output expression. Now here whenever we are calculating the output admittance or output impedance, that time input, now we need to remove the load. Wherever we are calculating that load we need to remove, and input source we need to make it 0. So by keeping Vs is equal to 0, Vs is equal to 0. If I put Vs is equal to 0, then what is the input expression? Now I am writing KVL at input, KVL at apply KVL at input side or input loop. What is that? Vs is equal to what can I write? Rs into IB plus HIE into IB plus HRE into VC. Now where Vs is equal to 0, I am making it to 0. So Rs into IB, now IB also I am taking out. IB if I take out, then I'll get RS plus HIE, RS plus HIE plus HRE VC. So now VC, how can I write? VC I can write it as, now IB I can write it as, now here I need to get the expression in terms of VC divided by IB. Now here output, now let me take the output expression. IC is equal to, what can we write? IC is equal to HFE IB plus, now this is the expression one expression. Now I am taking one more expression at the output, I am applying the KCL at output. IC is equal to HFE IB into HOE VC. So this is the expression. Now from this, now in this expression, if I put IB is equal to, now if I put IB is equal to, this if I substitute, then what I will get? Now from this IB is equal to, what can I write? From the expression 1, from equation 1, IB is equal to minus HRE VC divided by RS plus HIE. Now this I need to substitute in this expression. So then IC is equal to, this is equation number 2. So from equation 2, by substituting the above equation, so IC is equal to HFE minus HRE VC divided by RS plus HIE plus HOE VC. Now take the VC common and write the expression in terms of IC divided by VC. Now if I write like that, IC divided by VC is equal to HOE minus, I am writing this term first and this next, minus HFE HRE divided by RS plus HIE. Now this is nothing but what? Admittance. This is, we can write it as a admittance, Y naught. So Y naught is equal to HOE minus HFE HRE divided by RS plus HIE. Now this is the expression for the output admittance. Now here I can write admittance, output admittance is equal to, what is the expression? HOE minus HRE HFE divided by RS plus HIE. Now these are the 4 expressions we derived from the CE amplifier using H parameter model. Thank you.